Hi, today we're going to look at the relationship between the function, its derivative, and the second derivative. Now the most important thing to always remember is what you're given. For example, in this graph right here, we're given the derivative graph. So I'm going to identify that. This is the derivative graph. And it finds us the slope. And we know that if the derivative is above the x, the graph is above, we know the slope is positive, and if it's below, the slope is negative. Now notice what I did here. It didn't take me long to do that, and it can help me. So for the first question, it says, for what values is, let me focus here. For what values does the graph have a relative maximum and a relative minimum? Now it talks about relatives. This is our first derivative test. So the first thing I'm going to need are my critical numbers. For example, where is the derivative equal to 0? I need to find that. Since this is my derivative graph, where does it cross the x-axis? And we get -2, 0, and 2. And I'm going to set up, since it's my first derivative test, I'm now going to use my sign chart. Here's my first derivative. How does it make my function look? And my endpoints from -3 to 3, and I'm using -2, 0, and 2. And I graph it. But remember, if it's above, we're saying the slope is positive. So it's positive here, negative, positive, positive. So it's going up, down, up, and up. So where is there a relative maximum? Well, a relative maximum here occurs where the slope, remember, goes from positive to negative, up, down. So there's one at -2. And that is because the slope, the derivative, goes from positive to negative. Very easy to do. The next part says, for what values is the function concave up? Now this is different. This is our concavity test. Now some of you guys need to go back and look over this stuff. Okay, this is the concavity test. It's kind of a big one for us. This is basically where the slope of the derivative equals 0. Right? Remember, in other words, it's where the second derivative is 0. And I get the graph. I can find that. That's here, here, and here. So I get -1, 1, and 2. Now I can do my my concavity test, There's my second derivative. How does it make my function look? So from -3 to 3, we got -1, 1, and 2. This time it's my concavity, so I look at the slope of the graph. I'm going to use the slope of the derivative graph in this case. So between -3 and -1, the slope is negative. It tells me it's concave down. Between -1 and +1, the slope is positive. It's going up. It's increasing, so it's concave up. Between 1 and 2, negative, and then positive again. So it's concave down. Concave up. So I'm looking for where is this graph concave up? Well, it's concave up from -1 to 1, or from 2 to 3, and that is because our second derivative here is greater than 0. Easy breezy. Okay, now we want to graph this. Okay, so in order to sketch this, we need some information first. So we're going to start off with the basic shape. Do we have any points that we know in the graph? Nope, the only point we know is at -3, the value is 0. So what I'm going to do here is I'm going to graph this at x equals -3, we're at 0. Now is that the only point we have? Yes. Now that involves the function. Now we're going to use the slope. Well, the slope can tell me any relative max and mins. And that's important because that's our turning points. So there is a relative max. We know this at x equals -2. We got that from up here. So at -2, I know that there is a maximum. So from -3 to 2, it has to go up. I don't know where it goes, but there it is. There's my maximum. And let's see here. Any other? Is there a relative minimum? At 0, there's a relative minimum. And again, I can use my first derivative test for that. So it goes down and then up. So at x equals 0, there's a minimum. I want to make it down here. I don't know exactly where it's at, but there's a turning point. So kind of like this. Here's what my graph looks like. It goes up, it goes down, and here's 3 over here, and something's going to happen over here. So I got to use all. So I'm going to take a look right there. So that's the basic outline of my graph, with my turning points. Now I got to get some curves on this thing, and that's where the second derivative, concavity, comes into play. Do we have any POIs, some points of inflection? Yes, we get that from up here. My concavity changes at -1. My concavity changes at +1, and also at 2. These are my POIs. So here's -1. So down here is a POI. Kind of hard to see. At 1, there's a POI. There's my minimum. And at 2, there's a POI. Now remember what a POI does to the graph. That's where the concavity changes. And if we notice, from -3 to -1, it is concave down. So that means this is going to be concave down from here to here. Then the next two is going to be concave up, right? And then here it's going to be concave down, and then here, concave up. So my graph will look something like this, like a little worm. Hey! Alright. Very easy to do. These are kind of fun. You will see one of these like this on your test, so you gotta know how to do it. Alright, for part 2, number 2. Oh, hello, focus, focus. Sorry about that. Okay, try focusing. Let me focus this thing again. It looks fine. So let's try that. There we go. So for question number 2, it says find the equation at the POI. So that of course means we need the second derivative. So we go and do that. The first derivative, easy breezy, 6x squared minus 6x. To get the second derivative, 12x minus 6. Set that equal to 0 because it is a POI. I get 12x minus 6, so x equals, what's that, 1/2. Now to get the tangent line, we need a point. So I need the value at 1/2. And that's not too hard to do. This is 1/2 cubed. 1/8 times 2 is 1/4. This becomes minus, what's that, 3/4 plus 3. And I'm not quite sure what that is, so I'm going to cheat a little bit here using my trusty dusty calculator. 0.25 minus 0.75 plus 3. Change it. That's what's that, 5/2. So there's my point. So I got a point at 1/2, 5/2. Next we need the slope, y prime of 1/2. And that's going to be, easy breezy. Plug it into the first derivative. We get 6 over 4, because remember, 1/2 squared, minus 3. And again, I'm not quite sure what that is, so I'm going to use my trusty dusty calculator. 6 divided by 4, minus 3, and I get -3/2. And there's my slope. Writing my tangent line, y minus 5 over 2 equals -3 over 2, x minus 1/2. And there is our trusty dust. There is our equation. Alright, now next one it says, where does the function have a relative minimum? And of course we're back to the first derivative. Derivative. You know what? We're back to the first derivative. There we go. So we already got the first derivative, set equal to 0. So you're going to take your derivative, set equal to 0, and I get 6x squared minus 6x equals 0. Don't bring the 6x over, factor it out. I get x equals 0 and 1. Do my sign test. At 0 and 1. Now this is a parabola. Parabola is positive, positive, negative. So it goes up, down, turn around. Alright, there's where it's at. And where's my relative minimum occur? At x equals 1, and that's because the derivative goes from negative to positive. So you're going to see stuff like this in your tests and everything like that. So try these, practice them, okay? See you later. Bye-bye.